Please ask questions, interrupt. There's just a small group of us. Have fun. Let's do this. OK, so few slides. Don't worry, they look a little marketing-y, but they're going to go fast. Why .NET? I start with kind of just talking about .NET overall. I realize there's a lot of .NET devs here, probably mostly. Are there any people here that have never done .NET, don't know anything about .NET? There's like one person. They're like, OK. Anyways, even so, a lot of the time, if you've been doing .NET for a long time, there's kind of the question of why. Like you talk to someone, you look on Hacker News, why is .NET cool these days? Why would you do .NET? So we spend a lot of time thinking about that and thinking about like, why would you do .NET? How can we make it better at those things? Where are the areas where it falls short, and where can we push it further in those ways? So one way that .NET is really cool is it's an any platform thing. You can use it to build desktop apps, web apps, all the way out to gaming with Unity, AI. Honestly, with a talk like this, it's 1 hour, and I was like, had this huge list, and I had like, I'm going to show Unity, and I'm going to show this and that. It's a limited amount of time. I'll have a plug at the end where we're going to be covering tons of stuff at .NET Conf, which is a live virtual event coming up in September, and there's going to be presentations and all that kind of stuff. But this is, I think, a pretty compelling thing. There's a lot of languages where you can, you can build some pretty, intensive, like say AI or web cross-platform web stuff, maybe with C++, but you wouldn't want to build web apps with it, right? Or you can build a lot of stuff with JavaScript, but it's not always the best thing for everything, right? So .NET is a really cool thing where you can run your code anywhere, and that's really two things that are portable there. One is your code, that's your libraries, it's your application code can run in multiple places, but it's also your skills and your knowledge. You take time to learn new C# things, you learn new features, you find a favorite JSON library and you learn how to work with it, whatever. It's pretty cool to be able to run that in a desktop app, on a web app, wherever. As part of the whole kind of any developer thing, this is not like just kind of lip service. This is important to us that .NET is a viable platform that any developer can build apps with .NET. So that means it runs everywhere. Visual Studio and Visual Studio for Mac are the kind of full-featured development environments, and then Visual Studio Code is kind of all over the place now. And honestly, I think probably most people that even if you are using a full IDE, you're still popping over to Visual Studio Code quite a bit. It's a nice, lightweight, fast editor. So really, those are fully supported, cross-platform, all that stuff. You already know this. This is, I think, pretty cool. This is one where we try and update this pretty often, but it's impossible to keep up. These are pull requests to .NET. So these are people that have contributed to .NET. You can see like over in the middle of the ocean here, what are these guys doing? I don't know. but yeah, exactly. So, but this is really cool, and this is really neat to be able to see as we look just at GitHub stats, and see what's coming in. These are community-accepted pull requests. This is one where every now and then I'll get a frantic text from one of my bosses, and they'll say, like, send me an updated thing of this, because every month the bars keep going up, right? And we have to keep updating this as it goes. But it's really cool. This is something where there are significant parts of .NET. Let me show you this cool thing, which I just thought of, Matt Warren. So Matt Warren he's an MVP. He writes a bunch of cool stuff about just .NET in general. Tons of just deep dives into .NET Core stuff. Here's one post that he did, and this was from last December. But he looked at how much of what's that? Thank you. You were trying to get my attention. I'm like, I'm not going to be distracted here. Thank you. Let's just forget that ever happened. So, but this is really cool. This is a look at pull requests coming in. This is a look at percentage of contributions. So you'll see some things, like F#, tons of community contribution, Orleans, TypeScript, MVC, 76%, which is pretty crazy. Going down to things like even CoreFX Lab and MS Build, which are pretty intensive. They're not easy to just jump in and do a pull request. You're still seeing like 33% on some of those. So those are, excuse me, those are issues. But even issues, to file an issue on like CoreFX Lab, like I'm a little scared to do that. And there's people in there that are filing some pretty, specific things. On this thing, if you use this specific thing, you would optimize for memory, et cetera. Here as well, like look at this is pull requests, so this is actual contributions. Even with this, there's a huge amount of contribution from the community. So I think that's really cool that this is sort of like the promise of open source. People talk about if you open source things, then you'll get all these people jumping in. It happens for some projects, not always, and it's really cool to see it happening here. And I forget what the thing is. Present from current slide. From current slide, there it is. I used to know the thing for that. Cool. And even it's cool when people do analysis of .NET from, this is not Microsoft, this is Cloud Native Computing Foundation, and they just by looking at the stats, show .NET here as one of the top 30 high velocity projects. So .NET Core is super fast, and I think this is one of those really compelling things of why .NET compared to other platforms. When we started building .NET Core, we looked at how does it stack up against other things? And .NET Core really kind of started from some skunkwork projects inside the ASPNET team. And they looked at ASP.NET and they said, well, it's pretty fast actually. Like if you look at even traditional ASP.NET, Stack Overflow runs on just a few servers and it's been running on ASP.NET MVC, right? So it's pretty darn good. You compare that to some other like large web applications and they have like 10,000 PHP servers or whatever it is, right? But they said still it could be better because we had node envy, right? We'd look at the benchmarks and we'd say, wow, we're not very high up on the list. When I go over to Tech Empower, when we first started looking at Tech Empower, we would see, node would be, I don't know, say somewhere in the 60s, 70s, or maybe 50s at like 120,000 requests per second. And we were down here in the way down here. Like way down, you're scrolling and you're like, it's embarrassing. And we said, why? Why is that? We should be faster. It's compiled code. It's, we should be able to optimize. And we looked at things and we said, well, there's a lot of stuff that we just haven't made performance first class as we're developing, right? And so there's actually CI stuff. There are actual performance benchmarks for every check-in that are running live now. And they're looking at the benchmarks of how the performance is doing. And so these are the latest ones, and you'll see on this we are, let me see, number 11 here. Now this is on the Fortunes benchmark. We actually started with the plain text benchmark because we wanted to work up the stack, right? So when we started on this, again, we were super low on this, and we optimized for this from the kind of just server. All you have to do for this, if you look at the specs for these benchmarks, is kind of return a hello world. Like if there's a valid HTTP request, you return hello world, and then you do some basic HTTP handling. We were way down on this, and now you'll see on here we are, where are we, 11? 11, right? So there's a huge jam right here, and we're saturating at the network level now. So we're actually working with Tech Empower to get them better hardware so that we can, keep, we're gonna keep moving on. Otherwise, we'll just stop, right? We're done. So, but this is really cool, and it's actually, there's huge competition at this level. But another thing you'll see is some of the other ones, number one, Actix Raw, then there's Fast HTTP, there's Wizardo, there's Rapido, there's a lot of these that are like C or C++. They're not super easy to build an application in, right? So I like the performance and ease of use balance here that we've got. We've always had a pretty easy to use stack, and I think this is awesome. We can be proud of this, to look at this and go, wow, we stack up well. So we started with plain text, and then we've done a lot of work moving up the stack and just kind of steadily, when I say me, it's definitely not me, it's other people on the team. But it's really cool to see as they're continuing to just go like, okay, now what's the slowest thing? Now what's the slowest thing? So for this, things like Fortunes, this is actually something that's doing database queries and updates. And we're using Postgres because this is running, these benchmarks run on Docker, I believe. So they're running, this is against Linux, right? So we needed Postgres drivers to get faster. So we work with people in the community to speed up our Postgres drivers. So I think this also is a pretty compelling thing. If this is another one of those slides where I'm continually having to update it and hoping my bosses don't call me about it. But this is pretty cool here. Actually, there should be an animation that shows them moving. Huh? But you see here, like, now I think we can be pretty, now there's obviously great times to use Node.js. I'm not trying to bash Node.js, but I'm saying as a comparison thing, this is pretty compelling to say your code goes, you know, significantly faster on the same hardware. Let me see. Oh gosh. Awesome. Okay, so, and these are public benchmarks. These are ones where you can go and you can look at the code. People submit pull requests. Everybody, this is a great challenge. Everybody's pushing each other to go faster, right? So that's pretty cool. So I actually gave I was giving this talk at a conference earlier, and I had a conversation with another speaker, and she was saying, you know what, I'm just on .NET full framework. I'm not really moving to Core. When I see the presentations, it looks a little complicated, like you're doing all this stuff in the command line, and there's like all these packages, and I am pretty happy with just going File New Project in Visual Studio, so why would I bother with that? And so I said, those are great questions, let me think about it, and I changed my talk for the next day. So this slide was actually for her. And there's two things really. So one is, we kind of messed up in our demos, because you could always do Visual Studio, File New Project, run, and it worked. And we just kind of assumed that you would know that that still all worked, but we didn't do a good job showing that. So we work really hard so that the Windows Visual Studio experience just gets better for you. It's not like more complicated. But there are a lot of developers out there as we're kind of reaching out and we're saying, hey, we're fast, we're a compelling stack. You can develop on Mac and ship to Linux, you know, or AWS or Azure or wherever, right? When we're talking to those people, well, they're used to, on their Mac, pop open a console, you know, use Vim, whatever. And so those demos were for that, right? So that, I think that's important to say. But another, just kind of summarizing mostly what I've been talking about so far, there's that performance, I think, is something where we can, across the board, say performance is good for .NET and continues to get better. So the code I write today runs faster tomorrow, or maybe tomorrow, but you know, definitely in a month or two, right? The cross-platform side gives me flexibility. Even if I only build on Windows and only deploy to IIS or ship desktop apps for Windows, I still have that flexibility, which is nice. And that gives me things like I can test on Docker, right? I can build libraries and share those libraries with people that aren't on Windows. Side-by-side is a huge thing. I hadn't realized this as much until hearing from people. Okay, so we have large companies that invest in .NET. I think it was Morgan Stanley had like over 2,000 desktop applications used internally. You'd never hear about them, but 2,000 different desktop apps, which was giving them nightmares because it was really difficult to deploy them out to desktops, right? Because you can only have one full framework installed, and sometimes it kind of works, but not really. And so this is something where being able to deploy side by side is a real advantage. And this includes on the server too, right? So that was a hard lesson I learned as a young .NET developer. I was learning about new features, and this goes back a ways, but in .NET 2.0, not .NET Core 2.0, just .NET 2.0. And I was all excited about these features, and I went back and started telling the devs and telling the, hey, we're gonna use this, and they're like, why don't you go and talk to the server guys? And okay, I talked to the server guys. And they're like, we're not even considering thinking about .NET 2.0 for a year, maybe 2 years, And I was like, update the resume, move on to a new job, but still, it was sad, right? So anyhow, side-by-side is a very important thing. And then this last thing, easier, is I think it's important to mention, like the Visual Studio stuff works, all that. There are some things, like pain points of the project files got way simpler, right? You compare a project file, and a lot of these things bubble up from .NET Core across, but there's a lot of simplicity things that have been brought up. So that was my answers for her. Okay, let's talk about timeline, and I will speed through my slides a bit more here. So, how many people here were involved who were messing with .NET Core long before this the actual 1.0 release. And I'm sorry to all of you. I was there with you. It was not easy, right? And even .NET Core 1.0 was still kind of a little rough, right? But I think it was the right thing to ship at that point, because you can't be in beta forever. You got to ship something, and then people start building libraries, and then they'll tell you what you're missing and all that. So .NET Core 1.1 was a lot of these like, oh shoot, we missed that, thanks guys, you know, as people start testing it and seeing what doesn't work. .NET Core 2.0 was two big things from, well, I think a huge thing was .NET Standard. That was one of the huge things. And this was as people started trying to adopt .NET Core, they saw that we had removed or changed framework or changed APIs. We said, hey, we're not going to have like Active Directory or some of these other things on Linux, so we'll just not include them in .NET Core. And then people said, well, we can't adopt that. We need these APIs. So that was a huge, I think it was about 20,000 APIs we added for that. So then .NET Core 2.1 shipped at build, and then we've got .NET Core 2.2 and 3.0 coming up soon. So yeah, I mentioned .NET Core 2.0. Another thing that I think was kind of big with .NET Core or ASP.NET Core 2.0 was Razer Pages. And I'm debating, I'm going to show just real quick an application that we built. So we did a workshop the other day with, thank you. I apologize, and I wish I could say this is the last time, but it's not going to be the last time. You're going to have to tell me that. Okay, so we did a workshop the other day where we built a new project using ASP.NET Core. And part of the thing here was just going through and looking at Razer Pages. So Razer Pages is kind of a layer on top of MVC. It took me some time to decide that I liked it, because I have liked MVC for a while. I've actually written some books about MVC and taken some time to learn it, you know. So, but I do like Razer Pages, partly because I know it's a layer on top of MVC, and I can always get down to the things that were there. But the idea here is it's built on a page model, and so with the page model you have. So when we built MVC, you would have models, and then you would bind to your models and do stuff from your views. So your controller would populate, do things with your models, and then it would return data to your views. And then we said, oh shoot, well you really shouldn't bind directly to your data model, right? Because that's not good. You really should have a view model, so you're not overbinding, and there's all these bad things that can happen. So you really need a view model. And so then we're telling everyone over and over, you got to go create these view models, but you had to know to do it, and you had to do it yourself. And there's a lot of ceremony. You would be building a simple page that's listing a few things, and you would have, the views, the controllers, the model, the view model. You have 4 or 5 files, and all you're doing is listing a few things, right? So, and sometimes you want that, but a lot of times you don't need it. So, here's kind of what that looks like for. This is a page model. Here, this is something that's listing a bunch of movies, and it includes sorting and a few searches, right? So here we've got Entity Framework. I've got an iList of movie, and I have a method called onGet. Actually, I think it's onGet async. And so when onGet async gets called, here we've got a few query string things that does some querying on it, and then it just sets this movie. And then on the front end, it just binds to that movie. So let me show a simpler one here. This is not delete. Let's go to details. So details, I've got an onGet async, and it just queries based on an ID passed in, and then returns the page. And then on the front end of the page, we can bind to that. There's a lot more to it, but the idea here is if you haven't looked at Razer Pages, I think it is pretty worthwhile to learn it, and in fact it's the default as of ASP.NET Core 2.0. So, yep. Actually, I'm just going to not go to presenter mode. Oh, but then I lose on my. Yeah, sure. Okay. So .NET Core 2.1. So .NET Core 2.1 shipped at build. I got to do that. And there it is. So .NET Core 2.1 shipped at build, and some of the things I'll show demos on this, and we're going to shift to more demos at this point. .NET Core 2.1, we had global tools. So this was something, it's obviously very similar to other frameworks have this, like Node has global tools, et cetera. And the idea is that there's a lot of things, like for instance, .NET Watch is a package, it's a NuGet package that you can add to your project, and you could say, anytime I save a file, recompile. And it's really handy for if you're doing something like you're coding in VS Code and you want to just make a change and refresh your browser and see the change, right? But in order to use that, you had to keep going every project you wanted to use it in. You had to add this NuGet package. And and it's like, I just want it available all the time. So that's an example of something where we actually made that into a global tool. So it's installed by default when you install the .NET Core SDK. But also you can create your own global tools. I'll show you a little bit more of that. Span T sockets, so a lot of performance stuff that we added. One other thing that we've added here is this Windows compatibility pack, and that's to allow you to take advantage of Windows features within .NET Core if you're running on Windows. EF Core, I'm not going to show really any of this, but there are a lot of kind of changes or advances. One neat thing is data seeding. Data seeding used to be kind of pretty hacky. It's kind of like it's always going to be a little semi-hacky, but the new data seeding is actually kind of more of a first-class thing, and it supports migrations, which is cool. So when you're changing your data seeding, you can say like, okay, now I'm going to seed some new data or change around my seed data, and that works with migrations too. And then ASPNET Core, we'll look at all this in a second. So at this level with .NET Core 2.1, we looked at what are some of the pain points that you run into as a developer and ways that we can help make your day better. This is an example of .NET Core build performance. So this one is really kind of an obvious one. This is just awesome here. This is gonna take me out. So here we took, this is Orchard, the Orchard project, and it used to take 107 seconds to compile. It's a non-trivial amount of code. There's a lot of projects and stuff in there. And then with release, it got down to, actually it's lower than this now because this was for preview 2, but 10 seconds. So that's a huge chunk of time. So the idea is this makes it, when it's that much faster to compile, you develop differently, right? You're not worried to just compile, we run tests, all that stuff more often. So this is across the board. These are some big changes in build performance. This is that global tools thing that I was talking about earlier. So this is pretty simple to do. There's good docs on how to do this. So you can create your own global tools. And in fact, we've got there's a repo of community ones. So Nate McMaster, here it is, .NET Tools. So Nate's a developer on the ASP.NET team, and he's just started making a list of all these community ones. And some of them are kind of goofy, and some of them are awesome. So there's, like this one just came out, this dependency explorer for .NET, and it actually pops up. Has anyone seen this? It's like a whole screen thing, like it's a console application, right? But it's all like VT100 style. And you can arrow up and down, select something, and it'll expand out and show you all the dependencies. There's ones for docs. So Shane Boyer built this one to search docs using the command line. So there's tons of these that the community is building too. And you'll see that there are some that we're also shipping. So there's like the scaffolding code generation stuff is distributed as a global tool. This HTTP REPL I'll show you later is distributed as a global tool. And when you first install .NET Core SDK, we install developer certs, so you can develop against HTTPS, and that's installed as a global tool. So that's cool for two reasons, I think. One is it forces us to make it actually usable when we're shipping the stuff. And then two is if you're building your own global tools, you can go and look at the code. So and there's not a whole lot of code there. They're basically console applications. So that's that. Okay, let me see if I can remember. I think it's Control F5. No, Shift F5. Thank you. I should have asked earlier. Good. All right. SPAN-AT. So SPAN-AT is something that when we first built, so ASP.NET, I showed you the performance graphs. I showed you that ASP.NET used to be really slow, and then we started speeding it up. One of the ways we did that was by analyzing it and saying, what's taking so long? And as most people that write performance optimized code know, whenever you're garbage collecting, that kills your app, right? It kills performance because it pauses everything while you run garbage collection. Garbage collection happens when you use up a bunch of memory, and allocating memory by copying strings back and forth was the problem for Kestrel. That was like one of the biggest things. So we said, really what we need to do is take this data that's coming in from the request and just pop it into a chunk of memory, and then we're basically going to manage that memory access. And we wrote our own kind of stuff, and it was unsafe code, and it was horrible to look at, and it had these generators that would generate more code. It was bizarre. But it worked, and it allowed, it was crazy fast, right? So it allowed you to go and say, like, take this chunk, these 4 bytes here, and if they are these 3 letters, then move on, or whatever it is. That's a GET request, right? Something. So then they said, how can we abstract this so that we, number one, don't have this horrible code that's really tough. Anyone that wanted to contribute to Kestrel had to learn all that. And then number two, so other people can get these performance improvements. So they actually, one of the things they did here was use span. So span is exactly that. It's something where you can create a span from some bytes. So you say, you create a span and you point it at an array of bytes, you point it at a chunk of memory, and you say, and now you're able to access that and work directly against this span without allocating. So that's really the key thing, is don't copy that data around. Every time you copy strings, you say, this string equals this substring of this other string, and this string equals this. You've allocated all that memory, right? And there's examples, I don't have time to show it now, but there's examples all through the stack where then they started using this. So if you start looking around, you'll see tons of places where all of a sudden .NET Core all over the place got faster. So here's a cool blog post. This is Stephen Taub, who's total genius, and he writes really cool stuff too. And so he did all these performance improvements in .NET Core 2.1. He just analyzed how much faster things got using these memory improvements. So here's an example. This is a string builder. So this is code you could have written 10 years ago. There's nothing, you don't have to change anything here. You just run this, So this is what it looked like in .NET Core 2.0. It took 6 milliseconds and allocated some number of bytes. And then with .NET Core 2.1, 0 allocations, right? So this string builder is internally using the span. You don't change your code, all of a sudden it's just running faster. And it's running twice as fast. Okay, so here's another example. This is not a string builder, actually. This is a lowercase, and this is calling to lower. There's 2 examples. One is calling to lower when you actually have to change the string, and the second one is calling to lower when there's no changes needed. So the first one, still having to allocate, but twice as fast. The second one, no allocations and like a third as fast, right? So again, this is code that we've all written over the past however long you've been developing in .NET, and just by moving to .NET Core 2.1, you get these huge performance improvements. This is one I just stuck in because I wanted to mention it. I didn't know where to fit it in, but it got released around the .NET Core 2.1 timeframe. .NET Core, or ML.NET, is something that was an internal, it was something we used at Microsoft. Yeah, so there's several blog posts that go deep into it. I'm not an ML person. I don't really, the more I talk, the more trouble I'll get into, so I'm not going to. but I will show you a cool example, and I'll talk about why I think it's cool. So going out onto the ML repos, they have a samples repo, and it's cool where you can just learn by looking at the code. This is an example of a store, and it's trained on a bunch of sales data, so historical sales data. What it does the first time you run it is it dumps that data into a SQL database. Well, it's creating this dummy data, right? Months of historical records. And then when I run the thing, I'm going to look at my historical sales data, but it's going to predict future sales data. So this is pretty cool to be, and this is an example of something where So I'll talk to people and they'll say, well, aren't there already, there's other machine learning libraries out there. Why would you compete with that? And I think a better example here is, I'm a .NET dev. I've got a .NET application, and I'd love to sprinkle some machine learning in there, right? I mean, I'd like to use my skills, and I don't want to spend some time becoming an expert on something else. So I think that's really kind of the sweet spot. So here, this is, for instance, looking at country information. I can say, you know, in Germany, what were my sales? And so it's going through looking historically, and then for some reason, we're going to get a big spike in December. I'm not sure. Interesting. And so then let's look at products, and we'll say,
does it come with a guarantee?
it should. Okay, this was funny. I didn't want to look at the code. I just wanted to guess some product names. So I typed, and sure enough, gnome comes up, a silver fishing gnome. And so again, this is something where it's showing the changes in the, you know, so this is something where, here, let me see if I can show the repo. Samples. Yeah. So this is an example, this is the repo, and it also shows across these, many of them have written up where it shows, this is kind of a sad one, the binary classification of the Titanic. So you can, by looking at data, it'll tell you whether or not you're going to survive, whether or not a person's going to survive. So I don't know. I'm not sure who okayed that one, but so anyhow, this shows and explains the ML source code there. So, all right, Shift F5. Cool. All right, let's talk about ASP.NET Core 2.1. So these are some of the things that we included. And I think kind of in order, well, I don't want to pick a favorite. They're all really cool. HTTP Client Factory. The idea here is many applications make HTTP calls. So you've got a web application, or maybe it's even a console app or whatever, and you're making HTTP calls to another API. And it could be GitHub API, it could be whatever, all kinds of different APIs out there, right? Twilio or something. So we noticed people were having tons of boilerplate code where they were having to say, okay, I'm calling the GitHub API, so create an HTTP client and set all these things up for it and set up this, here's how I handle fallback and that kind of stuff. And so we made it a lot easier where you can, I'm actually not going to show the code, I guess, for that one, but I'll talk about it. We made it so that you could do a few things. One is you could create you could create one, you could say, this is my GitHub client. Whenever I create one, and I'll say, create a new HTTP client of, and just by string name, GitHub. And it would automatically say, okay, this is the endpoint, use these headers, that kind of stuff. We also did a few kind of more advanced things. One is we created a type client. So you can say, here's a GitHub client. You set it up for dependency injection. And then in any service you want to use it, you just inject that service and you start using it. So that's even that kind of higher level. You don't even have to say, create a new HTTP client. Any of that, you just say in my Razer page or whatever, I just take that service and start using it. And then the third level there is that we made it easier to set policies. So there are a lot of things, examples of, let's say I'm calling into an API that fails pretty often or sometimes. What do I do? Do I retry? How many times? Should I retry? Should I have an exponential back off and try 2, 4, 8, 16 seconds, whatever, and then die after that? So this, you can do things like you can set up policies and you can use libraries like poly.net to do that. And you also run into cases where you may have like rate limits, right? I can only call into like the SurveyMonkey API 500 times in a day, right? So I can say there are certain API calls that are not essential, and if I'm getting close to my limit, don't make those calls, right? So that's something where you can build those policies in. So Razer UI and class libraries and identity UI, I'll actually show that in a second. GDPR work, we did a lot of work as we went through a lot of pain inside of Microsoft. I'm sure a lot of you did too for GDPR compliance. And so with GDPR, there's several things you have to, not write there's handling of non-essential cookies. People have to accept cookies before you write non-essential cookies. But some cookies are essential for your app to operate, and you have to manually mark those, and so those are okay to be written under certain conditions. Then there's also things like I need to be able to download my data, personal data that a site is tracking on me. And I need to be able to delete myself, the right to be forgotten. I need to be able to go in and say, I want to remove myself from your site. So we went through and did all this stuff internally, and it was a nightmare. And we tried to make it simpler for everyone else to just build this by default. So in a file new project, those things are built in for you. So that's pretty neat. And then finally, SignalR. SignalR goes a ways back, but it didn't work on ASP.NET Core. We didn't ship a version for ASP.NET Core. We finally did with .NET Core 2.1. Yes, okay, so this identity UI is a library. This is an example. This was something where we needed it and we shipped it for you as well. So when you did file new project and said, yes, I want identity, we dropped a ton of files into your application because it turns out identity is complicated, and you have to do like log in, log out, but you also have to do forgot password confirmation, and then we have external login for OAuth and stuff. And so there's tons of different views. And those files were really just taking up space because you probably didn't want to edit them, because what if we change them in the future? They're just sitting there. And then you also ran into problems of, what if I created my application and I said, I don't need identity. And 2 days later, my boss says, hey, how's login going? And I'm like, oh no, now I have to file a new project and copy the files over and change the namespaces. So it's terrible, right? So then we said, it would be great if you could just right click and add identity to a project. And so, but then we had this problem of managing all these views. So we ended up actually shipping all the views in a NuGet package. So if I go, let's do that real quick. So I'm going to create a project without identity, and then we'll add it in. And I'll show you what that experience is like. So, okay, so we're in the new ASP.NET Core. This is a new laptop, so I'm not yet up to Web Application 485. Okay, so no authentication. So it's creating this new project. And then I'm going to scaffold, right-click scaffold, and I can add identity. So now I go in, I do right-click. So here's this new thing. I'm guessing you might not have seen that. It just kind of hides there. So this is neat because I can go in and I can say, well, I actually do want to change my login page. I want to put my company's logo and some stuff in there. And I want to change my registration page. Those are the only two. And then I'll change my, set up my, now here I haven't run it yet, so I don't have a context. I'm not going to go through this, but basically it drops just those two files in there. Later, if I want to add in some other stuff, right-click scaffold identity, and I can add in more views. If I don't want to use any of those views, I just delete them out of my project. So where are those views coming from if I deleted them? They're in a NuGet package, and the NuGet package has all those views. That's also cool because we can ship updates. If there's a problem with one of those things, we can ship an updated NuGet package, right? All right. And you can create your own. So in that file new project, do I still have it open? If I go here, new, so Razer class library. And it's actually super easy to do. You create, it's basically just Razer, and then this is already set up. When you build, it creates a NuGet package for you. So there's that. Cool. All right. Okay, so that is what shipped. Now let's talk about the future. So first of all, .NET Core 2.2. .NET Core 2.2, I think we said Q4 2018. And it's still, like, there's still things changing in it, but you can see now things are pretty well like getting checked in, and you can look at the code. So this is the official, there's an issue. I'm not presenting, thank you. we go. You know what would be neat is if machine learning like realized I'm typing like, cool. Here's this, you know, or what would be funny is if you like totally didn't tell me the whole time. So here's the overall schedule for ASP.NET Core 2.2. And some things that are in here. There's a lot of work for APIs and services. So there's work on controller conventions, things that make it a lot easier to set things for convention-based for APIs. So they eliminate a lot of repetitive code and also a lot of attributes, a lot of attribute soup. So that's nice. So here's an example. This is one with all the attributes you'd need to use, and here's one with all those attributes removed because of conventions. There's also work going on for OpenAPI. There's another thing that's pretty cool, and I'll show you that. This is, okay, so I'll do a new one. Okay, so I installed this global tool, and so it's .NET HTTP REPL. And I think I need to bump up my font size. Let's do that. That's better. Okay, cool. Cool. All right, so .NET HTTP REPL. So this allows me to, and the idea here really is that I can set this up as a browser in Visual Studio. So when I launch my application, so going back a bit, let's say you're developing an API in say Visual Studio, and it's a web API application, and there's no HTML front end for it, right? In my project, it's just an API. So then I hit F5, whatever, I run my application, and there's no web page, and I get a 404. And then I need to go, oh yeah, really, I guess I need Postman or something. I need to go and start pinging it, right? So what would be nicer is if I ran it and I actually got like, say, like a REPL that I could go and I could look at. I could inspect my API. Or I could bring up a cool looking Swagger page, right? So Swagger is a specification that allows for you to define an API. And there's a pet store. So there's this cool, the Swagger people have this example application, and you can go through and dig through it. So really what I would do normally is I would set this up inside my application, but I'm just going to show it pointing against this. So I'll say set base, and that's my endpoint. And then if I say ls, it doesn't know, it hasn't yet seen that there's a Swagger endpoint for it. So let's go in and tell it what its endpoint is. So the Swagger doc says, here are the APIs I support. So set Swagger. Oops. That didn't go so well. Set Swagger. Cool. So now it knows about the different endpoints. This is for a pet store. And now I can start going in. I can say ls store or cd store. Right? And so I can say inventory. Well, I can start digging around through it, right? So I think I need cd inventory. Right? So this is an example. Oh, and if this is kind of crazy. Cd pet. So here this supports put and post, and that's not very easy to do from inside a REPL. But what if I say, I'll try it anyhow, so I'll say post. So now it actually pops up into whatever application I've defined as my editor. And it pops, because I've done this, I've done something bad. It should have popped a new one. Okay, let's try it again. There it is. So it creates a temp file based on the Swagger definition, right? And I can go in and I can change it. And this isn't going to work. I'm not authenticated here, but it's something that this is how it would work on my local machine, right? And then when I exit, then it's going to try and post that up. And I failed, but So this is the idea. This is still something where it's not checked in. I actually went to a pull request and got the code and had to do all the stuff to compile it and installed it locally, but this is something that's on the way soon. And if you want to see more about it, this is, we did a recent thing on the ASP.NET Community Stand-Up. So that's at live.asp.net. And this is HTTP REPL. So this is Glenn Condren and Mike Lorobetsky, and they go through and, whoops, that's terrible. But they do all kinds, so they go through and do all kinds of crazy stuff, like showing all this off. So this is if you want to double click and learn more, that's where you go. Cool. All right, Shift F5. So those are some of the kind of the .NET Core 2.2 roadmap things. There's that. .NET Core 3 roadmap. So there's some really interesting stuff going on with .NET Core 3. So far, .NET Core has really been focused on web and cloud scenarios. You could build a console app, you could run on the web, but we didn't really have a lot for you for other scenarios. Which is kind of too bad. There's a lot of people that have other applications. You've got a WPF or Windows Forms application, right? You need to support that. So, so this is some fancy animation saying that I guess we're going to do better stuff. So .NET Core 3, some of the big things. One is support for WinForms and WPF frameworks. So it's important to clarify here, we're not shipping WinForms and WPF to Linux and Mac and all that, right? Which would be interesting, but that's not happening. So instead what we're doing is we're saying, well, wow, there's all these people that are building WinForms and WPF apps, and they can't use some of these cool features that we've been building for .NET Core all this time. Things like this performance and side-by-side and all that, which really would make a difference, right? Remember I talked about Morgan Stanley with those 2,000, or whoever it is, some large financial client with thousands of desktop applications. And so they would love to be able to do side-by-side, and this is an answer for that, right? So the idea here is the ability to use .NET Core 3. It's basically like scooping the brains of .NET Core 3 into WinForms and WPF, as well as ability to do things like allowing you to use UWP, and media controls using like the new web browser, using Windows 10 APIs. One other crazy thing is this app bundler. So this is basically bundle an entire application into a single exe. So this makes it really easy for distribution. Let us show that. Okay, so I'm going to this. So this is an application where I've got a few things in this. One is oh, I thought for a second I wasn't showing my desktop again. Okay, so here I'm going to look at my desktop, and I'm going to see, let's go 3 levels deep. So this is doing a pie chart based on file usage on here. Now here's something funny. This is a new laptop. I was just showing some demos here on it, and I was showing .NET Core apps, and then I wanted to show, somebody asked about something with, or no, I went to the Vue, a Vue thing yesterday, and so I installed Vue. So this is actually my Vue node modules. But all these are my .NET apps. I'm just saying. Okay, so this took this took 2 seconds to run, right? So here, let's pop over to our .NET Core one. Set a startup, cool. Control F5. And we'll do the same thing. Is it going? No, it's not. Okay. So this is that same application. And I should have said that pie chart is a Telerik control. They don't know anything. We didn't change anything. This is actually an old control. So as far as Windows Forms knows, as far as everything knows, it's the same code, right? Same controls. So here again, let's go into my desktop. Let's go 3 levels deep. Let's run it. So that took 300 milliseconds compared to 2 seconds, right? So, and the other crazy thing is it all still works. That same code, the same control, all that. So this is This is, again, this is not going to run on my Ubuntu machine, right? This is, but if I've got an application that is built for a .NET full framework, it's Windows Forms or whatever, I can take advantage of that. So one other crazy thing is, let's take this core and let's distribute it. So I'm right-click, publish. So I want to publish as a single file. Dump it on the desktop, because that's where we put things. So it's going through, and this is early. This is a super early preview of it. So the file size will continue to get better. This comes in at 64 megabytes, which is actually still pretty darn small, right? This is a single executable. So if we go out onto the desktop, and I can run this. Something else is using it, because it's still publishing, probably. Or something, I don't know. This wasn't part of my script. I should not be doing this. There it is, right? So that's crazy. And so there it is again. This is a single file executable. There's no crazy hidden dependencies going on. So again,
Does that pack the framework too?
yeah, it packs in the actual DLLs and all the framework stuff that you need. Yeah.
Can they do the binary?
So, and this is something where I'm going to get myself in trouble if I go too much farther on this, because I think it does depend on. What's that?
They keep talking.
Because I'll just be making stuff up. I mean, that's it. But my understanding is it is side by side because it allows for running, multiple applications. That's the reason we built it. So it has the dependencies it needs. So.
Does that make it pretty cool for deploying something into a Docker container?
Yes. I don't know if I'd want to run like a desktop app out of a Docker container. Maybe I would. I don't know. I don't want to think about that right now. Let's look at this. Here's a web browser. And this is an example of a place where allowing you to take advantage of newer controls. So the web browser control that we use is based on IE. And it's not super modern. So I think if I go to HTTPS HTML5 test, let's try that. So it gets 312 points out of, and you can't even read the 312 point, it's. So here it is, 489, and this is the ability to use the newer one. So this is the control that's based on Edge. Right, so this is upgrading. This is basically upgrading your Windows Forms and Windows Forms applications to be able to take advantage of these new UWP controls. So, pretty nice. Cool. Okay, yeah. So the side by side I think is huge. To your question, I completely made that up. I honestly really don't know. So that's why I do know that it's the side-by-side is the goal. So it's packages enough so that it'll run side-by-side there. The thing that I'm not sure about is, well, how does Windows Forms work? Because that's going to still require some other stuff, and so I don't know. The idea here, though, this is kind of the, if you are updating, so the kind of way forward for you, like the cross-platform, if you have web, ASPNET Core running on .NET Standard, et cetera, this is all your .NET Core stuff. And then you have these desktop packs to allow you for taking advantage of .NET Core stuff inside Windows-only applications. All right, we did that, crazy new. So the only real crazy new experiment I have time for is Blazor, which is cool because it's really fun. So the idea here is WebAssembly is a cross-platform, or it's a cross-browser thing. It's a specification. We didn't come up with it. It is a thing that all major browsers now support. And there's fallback for it, and I'm still presenting. There's fallback, but I caught it first this time. There's fallback for it using ASM.js as well. So the idea with this is anything that'll compile to a WASM file, WASM, can be executed at native speed in the browser. But it still runs inside the browser's JavaScript sandbox. So you get kind of all the safety, all the kind of, it's able to interoperate with the the DOM and all that stuff, but you get this crazy native speed. You also get the ability to work in your platform, potentially use your libraries, all that kind of stuff. So so what happened was Steve Sanderson is super smart. He's on the ASPNET team. He also built Knockout in the past and stuff. He was doing a presentation at NDC Oslo, and he's just like, let's look at some new browser standards. Here's WebAssembly. Hey, I wonder if I could get .NET Core or .NET running in WebAssembly, and he hacked it together. He used something called .NET Anywhere, which was unsupported, but it worked well enough for a demo. But then the Mono team is crazy, and they went and they're like, why don't we write this WebAssembly? And they built it with Mono. So the idea here is you're actually, you're able to, there's this whole kind of compiling thing, and you get a WASM file, and it runs inside that sandbox. So you get, because you're running inside of that, you get access to all those things, like the DOM events, you have web workers, you have any kind of modern standard, right? So when I show people this, they'll say like, wait a minute, is that like Silverlight? And it kind of is in the good way, and it kind of isn't in all the bad ways, right? So you're not worrying about, that was pretty good marketing, right? So I used to love Silverlight, honestly, because I could take advantage of like video and vector graphics, and it worked across browsers the same, and I got to write C#. But I hated it when like Firefox latest release doesn't support, or whatever. Like you had to wait on plugins, and so that was a problem. So this is the ability to, it's a web standard, it's going to interoperate cleanly, and it doesn't require any special browser. The browsers don't even have to know what it is. It's just a WASM file, right? So here's one other crazy thing about how it works. We take CS and CS HTML files, so you're actually like your Vue code, compile it into DLLs. And here's the crazy thing. We actually ship the DLLs down to the browser. So the browser has a mono .NET runtime. It's mono.wasm, and it loads the DLLs. So, which is, I originally thought, oh, they're probably compiling everything to WASM. But then I'd have to worry about changes with garbage collection, and I don't know how memory works and all that kind of stuff. So this actually is a .NET VM running in your browser. So, yeah. So, okay, so I have to say this, the disclaimer here, it's still technically an experiment. It's something that the team is building a lot of stuff on it, but it's not officially, a product yet. So I can't tell you to build your applications on it, but you should totally build your applications on it. So, no, you shouldn't. You should. Okay, so let's look at two quick examples, and that'll round our time out. So, first of all, I'm going to create, so to create a new application, you go to blazor.net. I'm really proud, I actually did the design for this. I'm pretty proud of that. And you could tell they're like, who can do the web page for Blazor? John, can you hack somebody? Yeah, sure. So, okay, so we'll create a new one. This is literally, I installed a V6 package. So that's all I needed to do to create a Blazor app. So now I'm going to go in. There's several different kinds. I'm going to do one with an API backend. But an important thing to know is, it is just, you can build something that's just static files. So you could host it on GoDaddy, as just like HTML. You can build something, if there's no .NET backend, you can ship it anywhere, right? Okay, so this application has a few things. It has a button where I click and it adds to the counter, because every Hello World needs that. And then we also have something that calls back into an API and gets a weather report. So we're going to bring that up, and that's going to fail because it does the first time I run it every time. Okay, and now let's see if it goes this time. There. It's supposed to set the server as a startup, but it doesn't always. Okay. So this is loading. Okay, so here's my counter, right? And then I can do fetch data, and this is getting data. So if I go over and look at the code for this, I think a compelling thing here is I'm doing a weather report getting data from the server. Here's my API. and it is using a class to return that data. So there's a weather forecast class. So here's that weather forecast class. And if you've done, single page application, you're sharing stuff, client and server, it's a pain to share a JavaScript model or a TypeScript model with a C# code. Here we're actually able to completely share that. So if we look at my fetch data, and it's able to, like, a few things. One, it's using this weather forecast, and then two, it's using this HTTP client. So that's all kind of, this is my logic for it, and that's my entire kind of front end for it. So one other thing I'll show you with this, and then I'll show you two quick other samples here. So let's go into here, and let's look at our network. So this is the thing I was saying. Here we've got a mono.js. We've got a few loader.js files. We've got this mono.wasm. And then this is the crazy mind-blowing thing. If we look at these, there's like a bunch of DLLs. System.dll. web app. So here's my web application 7.shared.dll, right? So, but two other things I want to show you with this. One is there is this Flight Finder application. So this is one that they wrote to kind of take it a little further, and what they're looking at specifically here is component models. How can we learn from, there's some pretty good component models already out there that are people are using for things like Angular and React, and how can we build something that learns from the best of them and makes it better or contextualized for our C# and Blazor. So this application lets me search for flights. And I'm not sure what I'm doing here. But this is one where I go through, I can create a short list and add the flights to there. So let's look at my back end for this. And the thing I want to show you with this is that we're using all these components. And there's things like an airport list component. So I've got like a data list, I have a short list. So I'm able to kind of nest and build. So for instance, my short list has, or my, whatever this has a short list flight segment, right? So I'm able to nest and build all these components together. The last one I kind of want to end with, which I think is pretty neat, is an experiment that they came up with where they're like, well, what else could we do that would be even more insane? And they said, why don't we try and run this inside of Electron? So Electron's what they use, like a lot of cross-platform apps are built. Slack uses this, VS Code uses Electron. Electron is this. It's amazing that it works, but it runs Chromium and Node in a desktop process, and then they do tons of like magical things. I went to a 1-hour talk. Brendan Forrester on the GitHub team that builds it showed this stuff, and I was like, it's crazy all the stuff they have to do, because you're taking a web server and a web browser, and then you're jamming them together and making them talk quickly together and all this stuff. So they took Electron for this, and all they did was hosted a Blazor application inside of that. So let's run that. So we just saw that application that had a counter, and it had a thing where it was getting weather report. And why is it not running? It is. Good. Cool. So there's that. So here, if I go like view, this is all the Electron menu. And then I've got my counter. So again, this is just totally experimental, and they're just like, well, would it work even? But they're trying to decide, and this is actually something where you can have some kind of feedback. If you install Blazor, which it's very quick, then there's a survey at the end, and you can say what you think about it, what you'd use it for. This would potentially, this was something that would run cross-platform. You could run a desktop app, Windows, Mac, and Linux with C#, but also using CSS and any JavaScript library and all that. I think sounds pretty neat. So that is, the huge disclaimers of, we still honestly, inside of Microsoft, we need to convince the bosses that it's something that we should ship and that customers want. So here's all my rah-rah stuff. If you are waiting on installing .NET Core or on using newer versions, reminder that you can run side-by-side. I always have, this is a snapshot point in time of my SDKs installed. There's .NET. And the last thing I have to call out is this. So this is where there's going to be more announcements. They're going to be showing off new stuff, a lot more stuff on .NET Core 3. And so this is, get involved in is anyone here speaking at this, by the way? You are? OK, cool. The CFP is just closed. Yeah. But we got, so previous .NET Conf last year, we had 70 submissions. This year, we had over 200. So there's a lot. The other awesome thing with this is there's stuff being broadcast from Channel 9 Studios, and then they're doing I think it's 24-hour worldwide live stream. So there are presenters all around the world. We have people, Nigeria, we have South America, we have every continent except Antarctica, and we just couldn't pull that one off. All right, I'm done. I'm sorry for talking fast. I wanted to cram a lot in. Please talk to me. I'd love to, hear more from you or talk. So awesome. Thanks, folks.